afternoon. I'm Mrs. Williams and I'm back with another video. Excuse the fact that I'm sitting on the floor right now. This is the only comfortable place in the room where there's good lighting. So just bear with me on that one. But anyway, we have been talking about transformations of geometric figures. And we've already talked about translations that move figures up or down or left or right. Today we introduced reflections of figures, which flips geometric figures over certain lines in the coordinate plane. But before we get into that, let's go ahead and write down our standard and our essential question before we move on. The title for today is Reflections of Geometric Figures. The standard is I can transform a geometric figure given a rotation, reflection, or translation. The essential questions are, number one, what are the different transformations that we can perform on a geometric figure? And number two, what are the effects of transformations on geometric figures? So today we explored reflections. We explored flipping a certain shape over the x-axis, over the y-axis, and other lines, and we created these notes, which look like these. But before we go on to teaching something new, I want to make sure that you fully understand what it means to reflect geometric figures over certain lines. So we're going to review that before we go on to something new. Reflections across the x-axis. When we reflect across the x-axis, that means the x-axis is going to serve as our mirror. So our reflection needs to be on the opposite side of that mirror, which gives us this. Our next example are reflections across the y-axis, in which case our y-axis is going to serve as the mirror. So our reflection will have to be on the other side of the y-axis. However, let's look at this one. Here, my reflection is not the same distance from the mirror. My original figure was only 1 square away, while this reflection is 3 squares away. That's not correct. Reflections have to have the same distance away from the line of reflection. So a proper example would be this. The blue triangle is 1 square away, and the green triangle is also 1 square away from the y-axis. Reflections across the line y equals 1. The line y equals 1 is here. So this line is now going to serve as our mirror. So my reflection will have to be on the other side. Notice how, again, if my blue triangle touches the mirror, then my reflection would also have to touch the mirror. We can also reflect other lines, such as x equals -1, which is this line. Here, this would be my mirror, and this would be the reflection. Again, notice how my triangle is 2 squares away from my mirror, so my reflection will also have to be 2 squares away. Reflections across the line y equals x. So when we want to reflect this, we will first have to draw the line y equals x, which is this one. Now this one can be a little bit tricky, but this is the line that's going to be our mirror. So we have to make sure that our pre-image flips over this line and not the axes. So this is what we would get. So in class, we explored the reflections. And during the assignment, many of you saw that the process can be very time consuming. Many of you struggled, and many of you got frustrated with the assignment. And honestly, that's okay. That's what I want it to, that's what I wanted to happen, because I wanted you to realize that using this process can be difficult. It's easy to make mistakes, and you have to pay attention to details using this method. But there is another way that we can find the reflections of geometric figures that's much easier and has less mistakes. This way is using a formula. And in this video, I'm about to give you the 3 most common formulas that we use to reflect geometric figures in the coordinate plane. Make sure you write them in your composition notebook, and I'll come back at the end to give you a short homework activity so that I can check for your understanding. So here are our 3 symbols for reflections that also represents the 3 most common reflections we are going to use in this course. The first one means we're going to reflect across the x-axis. The second one means we're going to reflect across the y-axis. And the last one means we're going to reflect across the line y equals x. So example 1, we have the formula for reflecting across the x-axis. And it simply means that we're going to take our original ordered pair and the y-coordinate is going to become opposite. So you can think of that negative sign as making it opposite of what it was before. An example would be the point A, 2, 3. So here is the point A, 2, 3 on the coordinate plane. And if I was going to flip over the x-axis, then my point now will become A prime, which is 2, negative 3. Notice how the y-coordinate went from 3 to negative 3. It became opposite. Another example would be B at the coordinate 1, negative 5. Now, if I was going to reflect this point over the x-axis, it would be up here, and then the point would now be B prime, 1, 5. In this case, negative 5 became positive 5. Example 2, we are reflecting over the y-axis. In this case, the ordered pairs will just have opposite x's. So example C would be here. And if we were going to reflect across the y-axis, C prime would be here at the point negative 2, 4. In this case, the x's are now opposite. 2 became negative 2. One more example would be D, which is at the point negative 1, negative 3. Flipping this over the y-axis will be this point, D prime, which is 1, negative 3. So in this case, negative 1 became positive 1. Example 3, ry equals x. In this case, x and y just simply switch places. The y value will now be first, and the x value will now come last. So for an example, we have the point E, 1, 5. So let's graph that. And our line y equals x. Reflecting over that means E prime will be at the point 5, 1. So 1, 5 became 5, 1. Let's do one more example. The point F. F is at the point negative 2, negative 3. F prime then will be the point negative 3, negative 2. Again, we just switched the numbers. Negative 2, negative 3 became negative 3, negative 2. So I hope using the formulas makes reflections a little bit easier for you. This way, all you have to do is normally make one of the coordinates opposite or just switch them around completely. If you wrote your notes down correctly, you should have your title at the top, then the foldable notes that we did in class, and at the bottom I have written my different symbols. And on the next page, I have my 3 examples of how to use the formula. So now I'm going to go ahead and give you your homework assignment, and I want you to try to use the formulas to answer the question. So your homework is to answer the following question. What would be the coordinates if we reflected them across the y-axis? So you're going to take these 4 ordered pairs and use the formula to find A prime, B prime, C prime, and D prime. For extra credit, if you graph both the pre-image and the image correctly, I'll give you 10 extra points. So I hope you found this video helpful. I hope you found it informative and it made calculating reflections a little bit easier for you. So until next time, bye.